Hi everyone. Today we're going to talk about historical neurological cases. As scientists, we study historical cases for the same reasons people study world history, to learn from them. In medicine, cases are how doctors tell history. Old cases can teach us about how doctors figured out diseases, anatomy, and medical mysteries. The cases we're going to discuss today are super important in the field of neuroscience. Let's get started.
Okay, so here's a list of the cases we're going to talk about. We're going to start with Kim Peek, who died just a few years ago, and he had savant syndrome. Then we're going to move on to Auguste Dieter, who was the first Alzheimer's patient. After that, we have Victor Laborn, who is more commonly known as Tan. He lost the ability to speak, and he taught doctors a ton about how speech works in the brain. Next, we have Phineas Gage, who is probably one of the most famous neuroscience patients in history. Finally, we have Henry Malaysia and Clive Waring, both of whom taught scientists about the hippocampus and memory. Our first case is about Kim Peek. Kim Peek lived from 1951 to 2009 and was known as a mega savant. A savant is someone who has superhuman intelligence. Kim could read both pages of a book at once and remember almost everything he ever read or learned. He could give you directions between any two cities in the world without a map. Even though many people with savant syndrome have autism, Peek didn't. He was just really introverted and shy. The cause of his savant syndrome was the absence of the corpus callosum, anterior commissure, and hippocampal commissure, in addition to an abnormally large brain overall. These parts of the brain are responsible for transferring information from one side of the brain to another. Imagine there are two little computers in your head. For most people, these computers are connected by a bunch of wires, and they can only control your body by working together like one big computer. In Peek's brain, his two computers could work independently at the same time because they weren't connected by the wires, so he could do almost twice as much work. Sometimes, doctors cut the connection between the two computers to stop seizures. This can result in something called split brain. Essentially, in split brain patients, their two computers start acting like they belong to two different people, which can have some really weird outcomes. Sometimes these patients will try to button a shirt with one hand, but the other hand keeps undoing the buttons. Kim Peek didn't have these types of problems because he had grown up with two computers that worked separately. This allowed Peek to process language on both sides of his brain, which is why he was able to read so quickly. However, even though he had a really good memory, Peek wasn't any good at math or reasoning problems, since that type of thinking requires both sides of the brain to communicate with each other. Peek's computers were able to reprogram themselves to learn language on their own, but they didn't have enough storage space and battery to learn how to do math problems on their own. Peek's condition taught scientists a lot about how the brain communicates with itself and what kind of information has to be transferred to both sides of the brain. But we're still trying to understand why his mind was so remarkable. He did inspire the movie Rain Man, which is about an autistic savant. This led to a lot of misconceptions about autism and savant syndrome. We now know that not all autistic people are savants or vice versa. Our next case is Auguste Dieter. Auguste Dieter lived from 1850 to 1906 and was the first person to be diagnosed with Alzheimer's disease. Alzheimer's disease is a form of dementia, or memory loss. This type of memory loss is unique in how it progresses with age. At first, Alzheimer's patients will forget information they just learned. Over time, this forgetfulness will start to apply to memories, family members, or even their present setting. These patients may not be able to remember where they are, or they might think they are reliving a moment from their childhood. This leads to a lot of confusion and disorientation. Dieter was not diagnosed until after her death. Dr. Alzheimer performed an autopsy and discovered that Dieter's brain was severely atrophied, and there were abnormal deposits between the nerve cells. Now, what does atrophy mean? If you were to sit down for years and years and years and years, the muscles in your legs would atrophy because they hadn't been used. Brain atrophy doesn't occur because your brain isn't being used. You have no choice but to use your brain. Brain atrophy usually occurs because of the lack of blood flow or illness. The deposits that were found in Dieter's brain led to the extreme memory loss and other brain problems that we usually see in a patient with Alzheimer's disease. Here on the screen, you can see a comparison between a healthy brain and a brain affected by Alzheimer's. The healthy brain has no deposits and fills up the skull. The brain with Alzheimer's is shrunken, weak, and full of deposits between the nerve cells. This case was the first time that a psychiatric disorder was linked to a biological molecule and helped scientists at the time differentiate between Alzheimer's disease and other types of dementia. Our next case provided a lot of information to scientists about how speech works in the brain. Victor Laborn lived in the 1860s. He was a normal guy living a normal life when he suddenly lost the ability to speak. He was admitted to the hospital. The only word he could ever speak was Tan, which is what he eventually came to be called. At first, Tan's other mental faculties were unaffected. Even though he couldn't speak in the way that we can, he still tried to communicate with his doctors, and he could still move and understand what others told him. Over time, he started to show other symptoms. He lost the ability to move the right side of his body, and his vision started to deteriorate. After a while, he developed gangrene, which is a very serious type of infection that can lead to the loss of a limb. He was examined by Dr. Paul Broca. After Tan's death, Broca performed an autopsy, where he discovered a large lesion on the left frontal lobe. A lesion is kind of like a tear in the body tissue. When a lesion happens in the brain, the affected area is essentially useless. Lesions can be very, very serious and cause all sorts of symptoms, depending on what parts of the brain they affect. In Tan's case, his lesion caused him to lose the ability to speak, and as it grew, it started to affect the ability to move as well. The symptoms caused by Tan's lesion led to the identification of Broca's areas. Broca's areas are the parts of the brain involved in language production and recognition and are located in the left frontal lobe. That's the area right behind your forehead. Tan is known as ground zero for Broca's areas. He was one of the first patients to ever exhibit this type of language problem, which is now known as Broca's aphasia. Aphasia is the inability to recognize or produce speech. Typically, only one of these problems happens at once. An aphasic patient may be able to recognize what is said to them, and they'll know what they want to say, but they won't be able to form any recognizable words. This taught scientists that language was localized to specific areas of the brain, not the entire brain like they had previously thought. It also taught us that brain injuries typically only affect the functions of the brain where the injury occurs. Our fourth case is perhaps one of the most famous neurological cases in history. Phineas Gage was working as a railroad foreman in the 1800s when an accidental explosion caused his tamping iron to stab through his head. His tamping iron, which is kind of a metal spike, entered just below his left eye and went through his face, into his brain, and out the top of his skull. He was immediately blinded in his left eye, but he somehow managed to remain conscious. He didn't lose any brain function or capacity either. However, Gage wasn't completely unaffected by this accident. After the incident, his personality changed drastically. His friends described him as no longer Gage. Before the accident, he had been friendly, energetic, and had a well-balanced mind. He was a well-known as respected businessman. After he healed from his initial injuries, he was explosive, angry, and temperamental. He began cursing and became unpredictable. Essentially, his personality did a 180. Gage taught scientists a lot about how personality works in the brain. His condition was the first evidence pointing to the importance of the prefrontal cortex in determining personality. Gage essentially underwent a lobotomy. Basically, the brain matter of his frontal lobe was scrambled up and partially destroyed. His drastic change in personality was the result of this impromptu lobotomy and told scientists that the frontal lobe has a large role in determining one's personality. Our next case is about Henry Molaison. As a young man, Henry Molaison, otherwise known as HM, suffered from epilepsy, a condition that causes seizures. His condition progressed with age to become completely debilitating. At age 27, HM finally resorted to an experimental procedure called an anterior temporal lobectomy to attempt to alleviate his seizures. Essentially, the surgeons went in and removed a section of the temporal lobe on each side containing the hippocampus. Your temporal lobe is right above your ears and covers the sides of your brain. After the procedure, HM's seizures were completely under control, but his memory was severely impacted. His memory about events before the surgery were very spotty. Some events and facts were still intact, but he never regained most of his memories. Additionally, HM was no longer able to form new memories. However, his intelligence, reasoning, perception, and many other mental faculties were completely unaffected. Also, his motor function and motor memory remained intact. He could still move the way that he wanted to, he just couldn't remember bits about his previous life. The effects of HM's surgery taught us many important things about the brain, specifically the hippocampus. The hippocampus can be seen above in the diagram, and was one of the main regions removed in HM's surgery. So his symptoms of amnesia suggested to scientists that the hippocampus was hugely important in memory consolidation. This was shown by HM's ability to maintain a memory for some time, maybe about 15 minutes, as long as he was actively rehearsing it. However, as soon as he directed his attention elsewhere, he immediately forgot that memory. This helped scientists delineate between different types of memory. HM still had working memory, or memory that required his attention, but due to the removal of his hippocampus, he lost the ability to convert those working memories into long-term memories. Our final case study is Clive Waring, who was an accomplished musician and conductor. On March 25, 1985, Clive contracted herpes encephalitis. The herpes virus usually only causes minor infections and cold sores. However, Waring developed a rare complication from this virus, encephalitis, or infection of the brain. This encephalitis caused extensive damage to Waring's hippocampi and lesser damage to his frontal and temporal lobes. This brain damage resulted in both retrograde and anterograde amnesia, meaning that most of Waring's past memories were lost, and he was also unable to form new memories. An example of this retrograde amnesia would be that Waring remembered that he had children, but was unable to remember their names. Additionally, although his musical skills were intact, he could not remember attending music school. In terms of anterograde amnesia, his memory would reset every couple of minutes. If his wife left the room to get tea, he would greet her when she returned as though she had not seen her in years. The most compelling evidence of his anterograde amnesia comes from the diary that Waring was given, which you can see here. Every couple of minutes, Waring's memory reset, and he felt as though he had awoken. Each time he would write about his waking in the diary, crossing out past entries because he could never remember his past awakenings. Essentially, Waring relived the first couple minutes after waking up for the rest of his life. Waring's case also provided scientists with great insight into the structures involved in memory and differing types of memory in the brain. Waring's amnesia was very similar to the case of HM that we just talked about, with the damage to his hippocampus causing him to be unable to convert working memories into long-term memory. However, a very important aspect of Waring's case is his retention of his procedural memory. Procedural memory is like your body's ability to remember how to do tasks. In most people, this would correspond to the ability to ride a bike or walk. But for Waring, his intact procedural memory meant that he was still able to play extremely complex piano and organ pieces. He was still able to sight read music and conduct. Additionally, Waring's ability to create new procedural memories was unaffected by his brain damage, meaning that he could still learn new skills and musical pieces. This suggested to neuroscientists not only was the hippocampus important for the consolidation of episodic memories, but also that the formation and storage of procedural memories was entirely separate both functionally and structurally in the brain. Let's wrap up the cases that we looked at today. Kim Peek had a super powerful brain, mainly because both halves of his brain could function separately. He taught scientists a lot about savant syndrome and influenced the movie Rain Man. Auguste Deter was the first identified Alzheimer's patient. She taught scientists about how different forms of dementia work in the brain and showed us that biological organisms can cause dementia. Victor Leborn, or Tan, had a brain lesion in Broca's areas. He lost the ability to speak and could only say Tan, which is how he got his nickname. He taught us a lot about how Broca's areas work in the brain. Phineas Gage was accidentally lobotomized during a railroad accident. After the accident, his personality was way different, which told scientists that the frontal lobe influences our personalities. Henry Malaysia, or HM, had a procedure to cure his epilepsy, but he ended up losing his memories. He taught scientists that the hippocampus is super important for forming new memories. Finally, Clive Waring had a really severe brain infection that damaged his hippocampus. However, he was still able to remember how to perform tasks, and he still kept his musical skills. He taught scientists that different types of memories are formed and stored in different areas of the brain. That's all. I hope you enjoyed learning about some famous neurological cases.